Hello guys! Welcome sa ating z-knowledgeTV. So, in this topic, we discuss all about the basic concepts of electricity. So, paano ba ito nag-work at paano ba ito nagsimula? Okay? So, let's proceed. So, for the objectives, after successful completion of this unit, you should be able to use appropriate SI units and standard prefixes when calculating voltages, currents, resistances, and powers. Explain the relationships between basic electrical quantities, voltage, current, and power. Use the appropriate symbols for independent and dependent voltage and current sources. Calculate the value of the dependent sources when analyzing a circuit that contain independent and dependent sources. And last, calculate the power absorbed by a circuit element using the passive sign convention. So, lahat ng ito ay pag-aaralan natin dito sa ating tutorial. Pero, before tayo mag-start, don't forget to like this video and click the subscribe button para ma-notify kayo sa mga next videos. So, let's get started. Okay. So, in this video, this is the simple electric circuit. Okay. So, makikita natin na in this simple electric circuit is meron tayong battery, meron tayong light bulb, at meron tayong probably switch. And syempre, hindi mawala yung wire. So, kapag nakikita natin itong circuitry na to, okay, so, alam natin na meron ditong nakapaloob na mga elements ng electricity. Okay? So, yung mga elements yun is yung tatawag natin na voltage. Okay? Meron tayong current at meron tayong resistance. Okay. So, ano ba yung electric circuit? So, let's define it first. So, an electric circuit is an interconnection of electrical elements. So, kung ano yung sinabi natin kanina na ang simple electric circuit is merong voltage, current, and resistance. So, that's what you call the electrical elements. So, ito yung different types ng electric circuit. So, meron tayong tinatawag na closed circuit, open circuit, short circuit, series circuit, at parallel circuit. So, lahat na ito is madidiscuss natin dito sa electricity. Okay? Let's discuss about the systems of units. So, ano ba itong system of units? So, our measurement, however, must be communicated in a standard language that virtually all professionals can understand. Irrespective of the country where the measurement is conducted, such an international measurement language is the International System of Units or SI units, adopted by the General Conference on Weights and Measures in 1960. So, itong tinatawag natin na SI units, so ito yung parang tinatawag natin na conventional na kung saan pinagkasunduan ng lahat ng professional na nag-aaral ng physics or sciences. Okay, so these are the 6 basic SI units and 1 derived unit relevant to this text. So dito, makita natin na iba't ibang quantity ay may nakapaloob na kanya-kanyang symbols or basic unit. So example, sa length, ang basic unit niyan is meter. So yung symbol niyan is small m. Sa mass, kilogram. So kg yung symbol. For the time, second. For the electric current, ampere. For the thermodynamic temperature, Kelvin. Luminous intensity, candela. Charge is coulomb. So dito, sa 6 basic quantities na to, is syempre, ang tutakal natin is about the electric current. So, ang SI units natin na ginagamit dito is ampere or capital A. So, ang mga kasama nito is yung, syempre, yung voltage. So, volts yung basic unit natin doon. Okay, then yung resistance, ohms naman ang basic unit noon. Okay? So, here are the SI prefixes. So, dito naman, kapag sobrang laki na ng value or sobrang liit ng value, pwede natin siyang gamitan ng different prefixes. So, example, meron kang 18 na zeros. So, 1 tapos may 18 na zeros na kasunod. So, papasok siya dito sa mga prefixes na to. So, alamin lang natin kung ano yung exact na prefixes para doon sa may 18 na zeros. Okay? So, example, ito. So, 10 raised to 18. So, ang tawag sa kanya is hexa, yung prefix niya. Okay? Or symbol E. Kaya, example, meron tayo 1,000 grams. Okay? So, kapag 1,000 grams, pwede natin siyang sabihin na ibang 1,000 is may 3 na zero. So, ibig sabihin, dito yung papasok sa 10 raised to 3. Okay, so, ibig sabihin, pwede natin i-convert yung 1,000 grams into 1 kilograms. Okay? Kasi, yung meron tayong 3 zero dun sa 1,000. So, ang equivalent ng 3 zero is 10 raised to 3. Or, kapag prefix niya, kilo. Okay? So, paano naman kapag 0.001? Okay, so kapag nag-move tayo ng yung 0.001 is pwede natin i-move ng 3 beses papunta sa right. So, para makuha natin yung full number niya. So, pero, ang mangyayari doon is kakabitan natin siya ng alinman dito sa naka-negative na sign. Okay? So, kung meron tayong 3 move to the right, so, dito siya papasok sa 10 raised to negative 3. Okay? So, ibig sabihin, kapag nag-move tayo ng 3 beses at pasok siya dito sa 10 raised to negative 3, ang magiging converted value na natin ng 0.001 ay magiging 1 times 10 raised to negative 3. Okay? So, pwede na siyang tawagin as 1 milli or 1 m. Then, kapit natin kung ano yung unit natin. Example, meter. So, magiging 1 millimeter. Okay? So, ganun yung paggamit natin ng SI units o ng systems of units natin. So, meron tayong different prefixes para dito. Okay. So, natakal na natin yung SI units. So, pero, the big question is, what is electricity and how does it works? Okay, so para mas ma-explain natin ang electricity, we need to zoom in the molecular into the atomic level. So, ganun natin siya dapat himay-himayin para mas ma-analyze natin o mas ma-explain natin kung paano nga ba nagsimula ang electricity o kung paano ito nag-work. Okay. So, let's define the matter. So, syempre, dito nagsimula lahat eh. So, matter is anything that has mass and volume. So, all matter is made up of countless tiny particles whizzing around. So, these particles are extremely dense. So, matter is mostly empty space. So, alam natin yun. So, matter seems continuous because the particles are so small and they move incredibly fast. So, ganun siya di ba? So, ganun siya kaliit. Kaya mabilis siyang mag-move. So, the matter that makes up all of the things is composed of a very limited number of building blocks. So, itong mga building blocks ay yung tinatawag natin na atom. So, bawat chemical element ay mayroong unique type of particle known as atom. So, ano ba itong atom na to? So, atom is made up of electrons and nucleus. So, atoms of different elements are always different. So the slightest change in an atom can make a tremendous difference in its behavior. Okay? So at dahil hindi natin nakikita ang atom in our naked eye, but only with scanning tunneling microscope can we get a glimpse of something fuzzy spheres. So para mas maunawaan natin ang electricity, we must go further and look inside an atom. So kailangan himay-himayin natin din yung atom kasi doon daw nagsimula yung electricity. So but this is where it gets complicated because yung inside ng atom ay hindi natin makikita. So we will use this representation of the inside of an atom. So this is what you call the Bohr model diagram. So ito ay yung tinatawag na Bohr model. So take note that it is not to scale and only two-dimensional. So this model is also known as the planetary model. So modeling the parts of an atom as planets orbiting a sun or moons around the planet. So parang kumbaga ito yung sun, then this is the orbits, and the blue circles is the planets. Okay? So, itong nasa gitna is what you call the nucleus. So, nucleus contains the protons and neutrons. So, ang protons at neutrons ay may parehong mass. But proton has an electric charge while yung neutron ay wala. Tama? So, orbiting the nucleus are what you call the electrons. So, electrons are outside the nucleus like a cloud surrounding the nucleus. So, ito yun, yung mga blue circles. So, that's what you call the electrons. Okay? So, these electrons are responsible for electricity. So, kaya doon nagsimula o nag-come up yung word na electricity. So, from the electrons. So, tanong na lang is, paano? Paano nangyaring ganon? Doon kinam up yung name ng electricity doon sa electrons. So, tuloy natin. So, an electron shell is the outside part of an atom around the atomic nucleus. Okay, so ito yung electron shell. Okay, yung nasa outer part. So, it is a group of atomic orbitals with the same value of the principal quantum number n. Okay, so the inner shell can hold 2 electrons. So, ito yun. Okay, ito yung inner shell, ito yung outer shell. Basta ang tanda natin, ang outer shell, siya yung pinakadulo. Ang inner shell, siya yung pinaka nasa first shell dun ng first shell mula sa nucleus. Okay? So, ulit. So, the inner shell can hold 2 electrons. So, 2 electrons lang daw yan. So, the second hold the 8 electrons. The third can hold 18. And there are elements with all 7 known shells. So, ngayon, paano natin sabi na sa inner shell o sa first shell, merong 2 electrons. Sa second shell, merong 8 electrons. Sa third shell, merong 18 electrons. So, dahil doon, dahil yon sa formulang ito, na electrons in a shell is equal to 2n raised to n squared. So meaning, added electrons always go for the innermost shell possible with a spot. Kaya nagkakaroon ng jumping of electrons into a hole. So ibig sabihin, bawat dito, okay, bawat orbits or bawat shells, meron din diyang mga holes. So kapag tumalon yung mga electrons natin, pumunta dun sa hole, so magkakaroon ulit siya ng vacant hole. Okay? So, hanggang sa mangyari, tuloy ng pag-jump yung mga electrons natin. So, kapag nagkaroon ng jumping ng electrons, so, meaning, nag-move yung electrons. So, that moving of electrons is what we call electricity. Okay? or what you call the flow of current. So electrons in outer shells have higher average energy and travel farther from the nucleus than those in inner shells. So this makes them more important in determining how the atom reacts chemically and behaves as a conductor. So because the pull of the atom's nucleus upon them is weaker and more easily broken. Okay, so the valence shell is the outermost shell of an atom. So this valence shell is the most or is the outermost shell of an atom in its uncombined state. So which contains the electrons most likely to account for the nature of any reactions involving the atom and of the bonding interactions it has with other atoms. So atoms of one element all have the same number of protons, but can have different numbers of neutrons and electrons. So, yung tawag na yun is isotopes. So, elements variants with different numbers of neutrons are called isotopes. So, the atomic weight of an element is approximately equal to the sum of the number of protons and the number of neutrons in the nucleus. So, yung electrons, which are far lighter than the protons in the nucleus, can relatively easily move. So, dahil mas magaan siya, so mas mabilis siyang mag-move kaysa doon sa mas mabigat. So, at ito ay mahalaga dahil yung movement ng electrons is what forms an electric current. So, this, sinabi ko na yun kanina. Yung jumping, kaya nagkaroon ng jumping, is nagmumove yung mga electrons. So, that moving of electrons is what you call electric current. Okay. So, what is charge? So, charge is an electrical property of the atomic particles of which matter consists. So, it measured in coulomb. So, the atom's protons account for the positive charge of the nucleus while the electrons for the negative charge. So, electrons has negative sign, protons has positive sign, but their charge is the same. So they have 1.602 times 10 raised to negative 19 coulomb. So in a stable, resting or rather neutral electrical condition, these charges balance each other out within the atom. So this will give the atom a net electric charge of 0. So for each positive proton, you will find the one negative electron. So para daw sila mag-zero. So in a ground state of the atom is at its lowest possible energy level. So however, maaari nating mabago ang atom's charge or energy level by causing it to gain or lose electrons. When the atom has fewer electrons than protons, so syempre, it becomes positively charged. So, pero, kapag yung atom ay mayroong more electrons than protons, the net charge swings back the other way. So, kabaliktaran naman mangyayari. So, it becomes negatively charged. So, positive charge is the absence of electrons. Negative charge is the surplus of electrons. And syempre, para maging neutral o maging balanse, so neutral charge. So, ang tawag doon. Dahil neutral charge is a balance between electrons and protons. So, when in a ground state or uncharged, it looks like we called an atom. And when charged, negatively or positively, instead ng atom, when there is a charge, kaya tawag naman iyon na negative or positive ion. Okay? So, ulit ha. Kapag in ground state or uncharged, so atom ang tawag natin doon. Pero kapag nagkaroon na to ng charge, tawag na natin doon ay either positive or negative ion. Okay? So, ano ba yung ion? So, a charged atom is called an ion. So, materials with high electron mobility are called conductors. So, sila yung mga kayang daluyan ng kuryente. Okay? Kasi sila yung may mataas na electrons. So, materials with low electron mobility are called insulators. So, sila naman yung mga hindi kayang daanan ng mga kuryente o ng mga electrons natin. Okay, so ang common place kung saan makikita natin ang conductor at insulator working together ay sa simpleng wire. Ang electrical wire ay mayroong copper core at plastic shell. So yung copper core is our conductor. And then yung plastic shell ay yung insulator. Kaya naman kapag hinahawakan natin yung plastic shell is hindi tayo nakukuryente. Kasi insulated siya, mababa yung electron mobility niya. Unlike kapag hinawakan mo yung copper mismo, so possible na daluyan ka rin ng kuryente. Okay? Kasi mataas yung electron mobility. So next, the following points should be noted about electric charge. So first, the coulomb is a large unit for charges. In 1 coulomb of charge, there are 1 over 1.602 times 10 raised to negative 19 coulomb or 6.24 times 10 raised to 18 electrons. So ganyan daw karami yung electrons sa isang coulomb. So thus, realistic or laboratory values of charges are on the order of picocoulomb, nanocoulomb, or microcoulomb. So, ganyan naman daw, kaliliit yung mga charges natin. So, according to experimental observations, the only charges that occur in nature are integral multiples of the electronic charge na mayroong negative 1.602 times 10 raised to negative 19 coulomb. Okay, so the law of conservation of charge states that charge can neither be created nor destroyed, only transferred. So thus, the algebraic sum of the electric charges in a system does not change. Okay? So a convention is a standard way of describing something so that others in the profession can understand what we mean. Okay? So take a look in this figure. So this is the electric current due to flow of electronic charge in a conductor. So in this figure, meron tayong batteries at meron tayong current. Okay? So meron din tayong isang load. Okay. So electrons move from the negative to the positive. So, ayun yung convention. So, the battery pushes out electrons from the one end and attracts from the other side. Okay? Kung saan yung isa ay nagpo-pull in, yung isa naman ay nagpo-push out. Okay? So, ayun yung convention. So, nagmumula daw yung electrons sa negative side, kung saan ina-attract siya ng kabilang side. Which is the positive side ng battery. So, kapag yung electrical path ay naharangan, example ito, naharangan. Okay? Ng kahit anong insulator or kaya naman naputol, so the electrons cannot continue to flow, thus stopping the electric current. So, the key to the flow of electricity is making a continuous electric circuit, connecting a wire between the source of electrons and attractor of electrons. So, ganun siya nagpo-flow. So, pero kapag naharangan nga o naputulan tayo ng wire, so no electricity ang magpo-flow. Okay, next. So, electric current is the time rate of change of charge measured in amperes. So, ibig sabihin, ang magiging formula natin dito is current is equal to derivative of charge dahil yung current is nakarespect sa time. Okay? So, take note na 1 ampere is equal to 1 coulomb per second. So, ngayon, so, kapag naman gusto natin makuha yung formula ng charge, so, pwede natin siya ma-derive using this equation. So, paano yun? So, bilan natin. So, cross-multiply lang. So, magiging dq is equal to I dt. Then, getting the integral part ng equation na yun. So, magiging q is equal to integral ng I dt. Okay? So, makakamap natin itong equation na to. Okay, so ano ba yung t sub 0 and t? So, ito yung first or initial na time at yung final time natin. Okay, kasi alam natin na ang charge o ang electrons is nagmo-move. Okay? So, two types of electric current. So, first is the direct current or what you call DC. Is a current that remains constant with time. So, meaning, kapag babasahin natin itong diagram na to o chart na to, okay, so pansin natin na kahit gaano kahit gaano katagal yung pagdaloy o pag-travel ng mga charge natin o ng electrons natin, so constant lang siya. Okay, constant lang siya na sabihin natin ang magnitude natin dito is 1. So, kahit gaano tumagal yung pag-flow niya, constant lang na meron tayong current na 1 amp. Okay? So, kaya siya tinawag na direct current kasi remains constant with time. Okay? So, ano naman yung alternating current? So, alternating current is a current that varies sinusoidally with time. So, ano may ibig sabihin na to? Kung pabase naman tayo sa diagram na to, papansin natin na in any time, so, yung current natin is pwedeng magbago. So, example, so in this one, so meron tayong 1 amp, and then in this part, meron tayong negative 1. Okay? So, papansin natin na sa first time natin, so pwede tayong magkaroon ng high peak na may magnitude na 1 amp. Okay? So pwede rin naman tayo na sa kabilang side is magkaroon tayo ng magnitude na negative 1 amp. Okay? Kasi yung alternating current is nagbabari sinusoidally. So, the question is, pwede ba tayo makuryente kapag hinawakan natin yung plug, yung mismong socket natin sa bahay? So, yes, pwede. Pwede tayo hindi makuryente. Kapag isa kang flash. So, sobrang bilis mo, so, pwede kang makahawak na yung pag-flow ng current is tumama dito. Tumama mismo dito. Okay? Kasi kapag tumama yan dyan, sa part na to, okay, so, meron kang 0 amp. So, walang kuryente. Tama? Kaso, hindi naman tayo isang superhero o hindi tayo si Flash para ganun natin kabilis na matansya na mahawakan yung kuryente na dadaloy sa part na to. Okay? So, kaya naman in real life, so, possible ka talaga makuryente. Kasi dahil mabagal lang tayo. Okay, so pwede nating mahawakan yung socket natin na nandito yung current. Pwede rin na nandito yung current. Nandito yung current dito. Or, ang masaklap, kapag nahawakan natin yung socket natin na nandito yung current. So, nasa peak siya. Okay? So ito yung alternating current. So, nagbabari siya sinusoidally. So, pwedeng nasa highest part ka o nasa lowest part ka. So, next. So, let's take an example. So, how much charge is represented by 4,600 electrons? So, ilang charge to yan? So, kung babalikan natin yung topic natin kanina, alam natin na yung maisip natin na formula dyan is yung tinatawag natin na current is equal to dq over dt. Tama? So, pero, alamin muna natin na ilang charge meron sa isang electron. So, each electron has negative 1.602 times 10 raised to negative 19 coulomb. Hence, masabi natin na in 4,600 electrons, kapag kinonvert natin siya into coulomb, ang isang electron merong negative 1.602 times 10 raised to 19 coulomb. So, kapag multiply natin yan, we can cancel out the electron. So, therefore, kapag na-cancel out natin yan, meron lang tayong isang unit, which is the coulomb. Which is right. Kasi, or which is correct. Kasi ang hinahanap natin is yung charge. Which is the unit of charge is coulomb. Tama? So, therefore, kapag pinag-multiply natin yung dalawang magnitude niya, 4,600 at negative 1.602 times 10 raised to negative 19, makakamap natin itong sagot na to, na negative 7.3692 times 10 raised to negative 16 coulomb. So, ibig sabihin, hindi pa natin nagagamit itong formulang to. Kasi conversion pa lang tayo. Next. So, for example, the total charge entering a terminal is given by charge is equal to 5t sine 4 pi t milli coulomb. So, calculate the current at time is equal to 0.5 seconds. So, dito, possibly, dito na tayo tumama. Na ang papasok sa isipan natin is yung formula natin kanina na current is equal to dq over dt. Kasi meron na tayong charge, meron tayong time. Okay? So, that's right. So, meron tayong equation na yan. And then, kapag sinubstitute natin yung given natin na charge ng 5t sine 4 pi t, okay, dito sa equation na to, so, we can solve for the derivative ng equation na yan. Okay? So, itong 0.5, hindi pa natin to magagamit. Okay? Kasi, tandaan natin na yung given natin is naka-perspective sa time. So, kaya siya muna yung dapat natin na i-derivative. Okay? So, ang derivative ng sine ay alam natin na cosine. Okay? Then, ang derivative ng cosine ay negative sine. So, kaya naman, kapag derivative natin to, so, gagamit tayo dito ng product rule ng derivative. Okay? So, ano yung product rule ng derivative? So, example, nag-derive tayo ng xy. So, mangyayari dyan is x dy. So, derivative, constant mo muna yung x. So, derivative mo muna yung y. Plus, copy mo muna yung y. Derivative mo na yung x. Okay? So, dito, meron tayong dalawa, 5t at sine. Okay? So, kaya product rule lang gagamitin natin dyan. So, therefore, kapag derivative natin itong 5t, so, fix mo muna natin yung sine 4 pi t. So, mangyayari is 5 na lang matitira. Tapos, fix natin yung 4 pi t. Okay? So, plus, fix naman natin itong 5t. Saka mo i-derivative yung sine 4 pi t. Ngayon, anong derivative ng sine natin? Di ba? Cosine. So, cosine yung lagay mo dyan. Kaso, hindi pa nagtatapos. Kasi, meron pa tayong derivative ng nasa loob. So, i-derivative daw natin itong 4 pi t in terms of t. So, anong sagot? So, ang sagot dyan is 4 pi. Just a constant na lang. Okay? Kasi sa constant ng derivative, or derivative mo mismo yung pinaka-variable mo, example, 5x. So, kapag derivative daw natin yan, yung constant na lang ang matitira. So, kasi ito, derivative ng variable is just 1. So, kaya 5 times 1 is 5. Okay? So, kaya ang sagot natin dito, kapag multiply natin pa siya sa 4 pi, is magiging 5t. Hindi. So, 5 times 4, pi. So, magiging 20 pi t. Okay? Then, saka natin mo i-multiply yung cosine for pi t. Okay? So, dito siya magkakama. So, magiging 5 sine 4 pi t plus 20 pi t cosine 4 pi t milliamp. Okay? So, ito na ba yung sagot? So, hindi pa. Kasi, din napapasok yung time natin na 0.5 seconds. So, tanong kasi, calculate the current kapag yung time niya is 0.5 seconds. Okay, so, ang gagawin natin dyan, substitute lang natin dito sa mga value ng t natin. Okay? So, hence, kapag nilagyan natin yan, so, magkakamot tayo sa gantong equation. Tama? I-substitute natin yung mga 0.5 dun sa t. So, kapag pinag-multiply natin, so, tanong, itong 0.5 na dito i-multiply or dito? So, syempre, saan ba siya nakadikit? So, dito siya nakadikit. So, dyan mo lang siya pag-multiply. So, pero, itong 0.5, since nakadikit siya sa amplitude natin, o sa magnitude natin, okay, so doon mo siya i-multiply. So, dito, doon mo rin siya i-multiply sa 4 pi. So, therefore, magiging sagot natin dyan is I is equal to 5 sine 2 pi plus 10 pi cosine 2 pi. And syempre, kapag using calculator na naka-radian, okay, naka-radian mode. So, makakuha tayo ng magnitude na 31.4159 milliamp. Okay, so take note na we are using 4 decimal places. Okay? Next. So, determine the total charge entering a terminal between 1 second to 2 seconds if the current passing the terminal is in this equation. So, meron tayong time na 1 to 2 seconds. So, sabihin, papasok sa isipan natin yung formula ng charge. Okay na, naka-integrate. Tama? So, yung dito tayo papasok. Kasi ang tanong naman sa atin is total charge ang hinahanap. Okay? So, using that formula, so substitute lang natin. So, meron tayong I. So, lagi lang natin siya dito. Then, yung T0 natin na 1. Tapos, T natin na 2. Okay? And using your calculator, so pwede mo siya i-direct eh. Or pwede kung ayaw mo mag-direct calculator, manual ka. So, ganito siya i-manual. So, kapag minanual natin, so, substitute natin, and then, saka mo i-integral yung bawat part niyan kasi dalawa siya. Tama? So, mangyari, integral ng 3t squared dt minus integral ng t dt. Okay? So, itong constant natin, pwede mo siyang ilabas. So, magiging 3 integral ng t squared dt minus t dt. Okay? So, ngayon, ano integral ng t squared? So, ang integral ng t squared ay t cube over 3. Okay? So, kaya lang, naka-multiplied siya sa 3. Kasi gawa na itong 3 to. Tama? So, minus, ano integral ng t? Diba meron tayong exponent na 1 dyan? So, magiging t squared over 2. So, huwag natin kakalimutan ang plus t. Okay? Pero, since na meron tayong given na limits para sa t, so, pwede natin siyang i-cancel out. Okay? Pero, palitan natin siya ng limits na 1 to 2. So, ano ibig sabihin yan? So, substitute mo daw itong 2 sa t at yung 1 sa t. Okay? So, gawin natin. So, mangyayari, 3 multiplied by 2 cube over 3 minus 2 squared over 2. So, ayun yung para kay time 2. So, pero, yung minus natin siya kay time 1. Okay, so 3 multiplied by 1 cube over 3 minus 1 squared over 2. Okay, so pwede natin ito makancel, di ba? Hindi nga ito. So matitira dito is 2 cube ay 8 minus 2 squared 4 divided by 2, 2 minus 1 cube is 1, 1 squared is 1 over 2 is 0.5 or 1 half, di ba? So 8 minus 2 ay 6 minus kalahati 0.5. So, ang magiging sagot natin is 5.5. So, ang sagot natin ay 5.5. Question is, ano yung unit? Tama? So, ano bang hinahanap natin? So, ang hinahanap natin is charge. So, therefore, ang unit ng charge ay coulomb. Okay? So, kaya kung pupunta natin itong power sa PowerPoint, so, magiging sagot lang natin is 5.5 coulomb. So, next. So, for the voltage, so voltage or potential difference is the energy required to move a unit charge through an element. So, it measured in volts. So, formula ng voltage natin is work over charge. Okay? So, take note na 1 volt is equal to 1 joule per coulomb is equal to 1 Newton meter coulomb. Okay? So, hindi to 1 Newton minus meter ha. So, 1 Newton meter siya. Baga parang ganito magiging 1 Newton meter per coulomb. Okay? Okay, so in this figure, so this is the polarity of voltage. So meaning, kapag daw ang voltage mo is nasa point A to point B, so magkakaroon ka ng positive VAB. Pero kapag nagsimula ka daw dito sa point B, from negative to positive, kakaroon ka syempre ng negative VA. Okay? So, polarity lang naman yan. So, pag sign polarity, gusto mo lang alamin kung ano yung sign ng voltahe mo. So, power and energy. So, power is the time rate of expanding or absorbing energy measured in watts. So, ang formula natin dito is power is equal to voltage times current. Okay. So, meron pa tayo ibang formula na pwedeng ma-derive using that formula at using yung mga natakil natin previously. Okay. So, ano bang formula natin ng voltage? So, ang formula natin ng voltage kanina is work over charge. So, ano naman formula natin ng current? So, ang formula natin ng current ay charge over dt. So, yung formula natin to, ilagay lang natin dito. So, mangyari, work over dq multiplied by dq over dt. So, cancel out yung dq. Matitira is dwork over dt. So, ito yung isang formula ng power in terms of work. Okay? So, in this figure, reference polarities for power using the passive sign convention is yung A is para sa absorbing power at yung B para sa supplying power. So, ano ibig sabihin yan? So, kapag sinabing absorbing power, ibig sabihin, siya yung kumukuha ng power. Pag supplying power, siya yung nagbibigay. Okay? So, sabi, ang lahat ng total power mo na inabsorb ay equal siya sa lahat ng total power mo na sinupply. Okay? So, that's what you call the law of conservation of energy. So, the algebraic sum of power in a circuit at any instant of time must be 0. Okay? So, kaya naman sinabi na yung lahat ng total power absorbed ay equal siya sa total power supplied. Para kapag pinag-sum natin yung dalawang yon is equal siya sa 0. Okay. So, energy is the capacity to do work. It measured in joules or J. So, ito yung formula ng energy natin. Okay? So, work is equal to integral part ng P dt, or pwede mo siyang sabihin na work is equal to the integral part ng VI. So, let's take this example. So, an energy source forces a constant current of 2 amp for 10 seconds to flow through a light bulb. If 2.3 kilojoule is given off in the form of light and heat energy, calculate the voltage drop across the bulb. Okay. So the total charge is this one. Tama? Kasi nagkamap lang naman natin siya sa formula natin kanina na current is equal to charge over time. So, getting the equation ng charge, so cross multiply lang natin. So, dq is equal to I dt. So, ibig sabihin na itong triangle ito is change. So, ganun din yung ibig sabihin ng derivative. Okay? So, ngayon, meron daw tayong change ng okay. So, ngayon, meron tayong given na current na 2 amp at meron tayong time na 10 seconds. So, substitute lang natin siya dito sa dalawang to. So, mangyari is meron tayong 2 amp multiplied by 10 seconds. So, therefore, yung change ng charge natin ay meron tayong 20 coulomb. Okay. So, paano natin magagamit yan para makakompute natin ang voltage drop? So, the voltage drop is by using this equation, by using this formula. So, ang work natin o ang energy natin is given, di ba? 2.3 kilojoules. So, lagi lang natin siya dito. And then, meron tayo na compute kanina na charge na 20 coulomb. So, kapag pinag-divide lang natin yan, so, makam up natin itong equation. Tama? So, the answer is 115 joule per coulomb. Okay? So, ang itong joule per coulomb, ang equivalent na to ay volts. Okay? So, kaya naman, pwede mo siyang sabihin na meron tayong voltage drop na 115 volts. Okay? So, that's the answer. Next. So, find the power delivered to an element at time is equal to 3 milliseconds if the current entering its positive terminal is, meron tayong current na 5 cosine 60 pi t. And the voltage is, dalawa. So, meron tayong 3i at 3 di over dt. So, sabi is kunin natin yung power using this voltage. So, if voltage is 3i, so ano kaya yung power? So, alam natin na ang power is equal to VI. So, meron tayong VI kasi ito yung V na gagamitin natin. Yung current is ito. Okay? So, pero, bago natin sila i-substitute, so, unahin mo natin itong VI. So, mangyayari, kapag ito, sinamshoot natin din sa V, so, pwede natin itong magawa. Tama? So, 3i multiplied by I is equal to 3i squared. Or then, kapag sinamshoot natin yung I, so, magiging ganito na itsura. Okay, naka-squared na yung current natin. Or pwede yung gawin, direct na. So, gawin nyo na agad is 3i 5 cosine 60 pi t. Okay? Kaya lang, ganun din. Diba? Substitute nyo rin yung I dito. So, kaya pwede nyo mangyari is 3, 5 cosine 60 pi t squared. Okay? So, and kapag sinimplify natin yan, makakuha tayo ng power na 75 cosine squared 60 pi t. Okay? And then, since na meron tayong given na time na 3 milliseconds, so, using yung na-derive nating formula, na 75 cosine squared 60 pi t, so, makakamap tayo sa ganito. Kasi, i-substitute lang naman natin yung time na 3 milliseconds dito sa t. Okay? So, therefore, the answer is 53.4667 watts. Okay? So, meron daw tayong ganyang power kapag ang voltage natin is 3i. So, paano naman kapag 3 di over dt ang voltage natin? So, using again na formula ng power, so, substitute lang natin yung voltage sa V. Okay, dito. Lagay lang natin dyan. So, therefore, ito yung mag-i-itsura ng equation natin. Okay? So, pwedeng gawin nyo is pag-multiply nyo na itong constant natin na 3 at itong I. Okay? So, ito yung makakuha nyo. Saka nyo, i-derivative sa 5 cosine 60 pi t. Kasi, i-derivative din daw natin yung I. Okay? So, therefore, kapag pinag-multiply natin itong dalawa, makakuha tayo ng 15 cosine 60 pi t. Okay? At syempre, kapag derivative natin to, again, the derivative ng cosine ay negative sine. Tama? So, therefore, kapag derivative natin to, so, since itong 5 is just a constant, so, fix natin yan. So, 5. Okay? Multiplied by derivative ng cosine is negative sine 60 pi t. Okay? Pero, kailangan pa rin natin yung derivative din nasa loob. So, derivative ng neto ay 60 pi. So, just multiplying all the given. So, makakuha tayo na power na negative 4,500 pi sine 60 pi t cosine 60 pi t. Okay? So, again, since na meron tayong t na 3 milliseconds, just substitute it here. Okay? So therefore, makakakuha tayo ng magnitude na power. Okay? So, lagyan lang natin yung T. So therefore, the power is negative 6.3958 kilowatts. Okay, so that's the answer. Okay, so example 6. So how much energy does a 100 watt electric bulb consume in 2 hours? So, meron tayong formula na work. So, work is equal to integral ng P dt. Tama? So, ito is kapag naka-integral part. Pero kapag hindi, kung gusto natin makuha yung pinaka-magnitude na agad, so, this formula will help. Okay? So, dahil halos same lang naman siya. Kasi itong integral part natin is naka-product. Okay? Naka-multiplied lang naman din sila. So, ibig sabihin, kapag meron tayong magnitude na ng power, at meron tayong magnitude na ng time, so, applicable na to. Okay? So, therefore, we just have the given in this formula. So, nangyari, 100 watts multiplied by 2R. Okay? Pero, di ba ang unit natin ng work is just a watt second. Tama? So, kaya itong goal natin. Makuha natin yung time na in seconds. Okay? So, kapag kinonvert natin 2 hours into seconds, so, meron tayo 60 minutes in 1 hour, at meron tayong 60 seconds in 1 minute. So, therefore, we can cancel out the hour and the minute. So, matitirang unit natin is seconds. So, kaya naman, kapag pinag-multiply natin yung lahat ng given natin, okay, 100 times 2 times 60 times 60, so, makakuha tayo ng 720,000. Okay? And using the prefixes ng units. So, itong tatlong 0, is pwede natin ma-convert into kilo. Okay? So, therefore, kaya siya nag-come up sa ganitong formula, ganitong sagot. So, pwede natin siyang masabi na 720 times 10 raised to 3. Or itong 10 raised to 3 ay just a K. So, kaya siya naging 720 kilowatt seconds. Okay? So, another unit na pwede natin masabi sa kanya is that itong watt seconds ay equivalent ng joule. Okay? So, therefore, kapag meron tayong 1 watt second, meron tayong 1 joule. Okay? Kaya naman, itong sagot natin na 720 kilowatt second, equivalent din siya sa 720 kilojoule. Okay. So, ano pang ibang pwede natin makuha ang sagot? So, pwede natin makuha yung nakikita natin sa mga electric bill na naka-watt-hour. So, pwede yun. So, ibig sabihin, kapag naka-watt-hour siya, okay, so, we can just multiply the given 100 watt times 2 hours. So, therefore, sagot natin is 200 watt-hour. Okay? So, next. So, circuit elements. So, element is the basic building block of a circuit. So, we have different types of elements. First one is the active element, is capable of generating energy. So, lahat daw ng element na capable ng mag-generate ng energy o magbigay ng energy is what you call the active element. And ang mga examples niyan ay generators, batteries, operational amplifiers. So, sila yung mga element na nagbibigay ng energy sa other elements. Okay? So, ano naman yung tumatanggap ng energy? O, sila yung mga hindi kaya makapagbigay ng energy. O, so, tumatanggap lang sila. So, sila yung passive element. Okay, so example ng mga yan is resistors, capacitors, and inductors. So the most important active element are voltage or current sources that generally deliver power to the circuit connected to them. Okay? So sila yung importanting element na kailangan natin makuha o malaman. Okay. So there are two kinds of sources, independent and dependent sources. So unahin natin ang independent source. So independent source is an active element that provides a specified voltage or current that is completely independent of other circuit elements. So naka-independent siya, okay, sa other elements. So in this figure, so yung A is for constant or time varying voltage. Okay, kapag nakita mo is naka-circle yung source natin sa circuitry. So therefore, independent source siya. Okay? So, sabi naman, siya yung constant voltage. So kapag ganito nakita natin, alam natin na yung voltage natin ay DC. Okay? Or yung na-topic natin kanina na direct current. Okay. So, paano naman sa current? So, sa current is same as circle. Okay? So, ayun yung symbol ng independent current source natin. So, paano naman kapag dependent? So, ang dependent source is an active element in which the source quantity is controlled by another voltage or current. So, siya naman yung nakadepende sa other quantity natin o other element natin. So, magiging symbol natin dyan is naka-diamond. Okay? So, kapag yung diamond nakita nyo, ibig sabihin, dependent source siya. So, naka-dependent pa yan sa other element natin. Okay. So, yung A is dependent voltage source. Yung B is dependent current source. So, meron tayong different types ng dependent sources. So, first is the voltage controlled voltage source or what you call VCVS, current controlled voltage source CCVS, voltage controlled current source VCCS, and the current controlled current source CCCS. Okay, so lahat nito is kaya natin ma-determine o ma-define dahil sa pangalan lang nila. Okay, yung voltage controlled siya daw yung voltage source na kinokontrol ng voltage. Sa pangalawa naman, siya yung voltage source na kinokontrol naman ng current. Pangatlo, siya yung current source na kinokontrol ng voltage. Then sa pang-apat, siya yung current source na kinokontrol ng current. Okay, so mamaya sa example natin, may mag-gets natin o maintindihan natin paano nga ba sila kinokontrol. Okay? So, dito, example. So, calculate the power supplied or absorbed by each element in the figure below. Okay. So, in this circuit, so, meron tayong different sources. So, meron tayong voltage source at meron tayong current source. So, since na voltage source natin is circle, so, siya yung independent voltage source. Okay? So, yung current source natin, since na nakadiagonal siya, dependent current source yan. So, ibig sabihin, nakadepende siya sa current. Kasi, yung given natin is may I. So, ibig sabihin, itong point 2, multiplied ba siya dun sa I? So, ano itong I natin? Ito yun. Okay? So, ibig sabihin, itong current source natin is current controlled. Okay? Kasi kinokontrol pa siya itong mismong current natin na 5 amp. Okay? So, for the solution, para sa P1, so, ito yung P1 natin. So, ano daw to? Power supplied or absorbed? So, malalaman natin. Okay. Using the formula ng power, which is yung PI, okay? So, yung voltage natin is yung mismong given, which is 20 volts. Okay? Ano naman yung current? So, ang current is itong current mismo natin na 5 amp. Ngayon, pansinin niyo yung arrowhead. Saan yung arrowhead nakaturo? So, papunta sa out. So, ibig sabihin, lumabas siya mula dun sa source. Tama? So, kung lumabas siya mula sa source, is siya yung nag-supply. Okay? Siya yung nagbigay. Tama? So, therefore, kapag gusto natin makuha yung magnitude niya ng power, so, just multiplied lang yung 20 at yung 5. Pero, ang magiging sign natin sa 5 is negative. Kasi siya yung nagbigay. Ibig sabihin, nabawasan siya. Tama, siya yung nawalan. So, kaya negative. Okay, so therefore, 20 times 5 is 100, pero naka-negative sign. So therefore, ang power natin is negative 100 watts. Okay, so therefore, since siya yung nagbigay, siya yung nag-supplied, so power, supplied siya. Okay, so next. Para naman kay P2. So, si P2, same yung formula na gagamit natin, VI pa rin. So, ang voltage natin is yung 12 volts. Okay? Yung current is yung current din na 5 amp. Okay? Kaya lang, ang pansin natin yung arrowhead, nakapapunta sa kanya. So, since napapunta sa kanya, ibig sabihin, siya yung mag-a-absorb. Okay? So, since siya yung mag-a-absorb, so, ang magiging sign natin kay current is positive. Kasi positive yun. Kasi binigyan ka pa eh. So, positibo sa yun. So, therefore, the magnitude of power para kay P2 ay 60 watts. So, since na siya yung nag-absorb, so, absorb power ang tawag sa kanya. Next, para kay P3. So, si P3, meron tayong voltage na 8 volts. Pero, iba na yung current na nag-supply sa kanya. So, ang current na nag-supply sa kanya is 6 amp na. Okay? So, question is, ano kaya yung sign convention o magiging sign ng 6 amp natin? So, negative ba siya o positive? So, since na yung arrowhead is papunta sa kanya, so, absorb yun. So, therefore, since na umabsorb siya ng power, so, positive sa kanya yun. So, kaya naman, ang sign natin sa kanya is positive. So, kaya kapag kinumpit natin yung magnitude ng power 3 ay 48 watts. And then, tinatawag siyang absorb power. Okay? Kasi siya yung umabsorb. Next. For P4, so, ito yung P4 natin. So, current yung source natin. So, meron tayong voltage na 8 volts. Bakit 8 volts? Kasi, same siya sa terminal nitong 8 volts natin na P3. Okay? So, sharing sila sa node na to, o sa terminal na yan, at sa terminal na to. So, ibig sabihin, since connected sila, pare sila ng terminal, so, ang tawag sa kanila is parallel. Okay, parallel connection. Okay, so, since in parallel connection sila, so, meron din tayong 8 volts dito. So, therefore, gagamit natin voltage kay P4 is 8 volts at yung current ay itong current niya, which is 0.2 I. Okay? So, para makuha natin yung pinaka-magnitude ng P4, so, itong I, substitute natin yung 5 amp. Kaya mangyari, itong part na to is magiging negative 0.2 multiplied by 5 amp. Or, yung sagot sa kanya ay, so ang sagot sa kanya is negative 1 amp. Okay? So, question, bakit siya negative? Okay, bakit negative yan? So, tingnan mo mabuti, yung arrowhead. Arrowhead is paalis sa kanya. So, pwedeng pag ginanyan, nilagyan natin siya dito, so, ibig sabihin, lumabas yung current. Okay? So, palabas. So, kung palabas sa kanya, so, siya yung nag-supply. Okay? So, since siya yung nag-supply, nabawasan siya. So, negative sa kanya yun. Kaya negative yung sign. Okay? So, therefore, the magnitude ng P4 ay negative 8 watts. Yan siya yung supplied power. Okay? So, tatandaan na kapag nabawasan ka, o ikaw yung nagbigay, so, supplied power ka. Kapag ikaw yung nadagdagan, ikaw yung kumuha, so, absorb power ka. So, kung i-check natin using yung law of conservation of energy, wherein sabi doon, lahat daw ng total power na inabsorb ay equal sa total power na sinupplied. Okay? Or equal siya sa lahat ng sum nila ay equal siya sa 0. Okay? Kaya naman, kapag pinag-add natin lahat ng power, so, makakama natin sa 0. Kasi, total power supplied ay equal sa total power absorbed. So, diyan natin malaman kung tama lahat ng sagot natin sa power. Kapag ang total nila is 0. Kapag hindi, so, ibig sabihin, may mali na. Okay? So, yun lang. So, that's the end of this presentation. So, thank you for listening. Thank you for watching. So, God bless.